Hi students, in this video we're going to look at how to sketch parabolas written in turning point form, or basically called using transformations. Perhaps after watching this video you should be able to understand the transformations that can be applied to parabolas and then use those transformations to sketch new graphs. That's what we want to be able to do from this video. Alright, so the biggest things we want to remember, guys, are that parabolas are the graphs of quadratics. Another good thing to remember is that we can find our y-intercepts when the x value is 0. Alright, now the simplest form of our quadratic, y equals x squared, right, often called our base form, it has a turning point of 0, 0, and we can see that here with our red graph. Turning point of 0, 0. Now the turning point can be translated or moved by applying a couple of different transformations. The first one is using this value inside the brackets with our x term, and it moves our turning point horizontally. Now, the key thing with this formula is in between x and h, it's a minus sign. And you might know that with your study of negative numbers, negatives can often mean opposite or different direction, opposite. So that means when you look at this formula, okay, how far the turning point has shifted horizontally is actually the opposite of how it looks in your formula. So for example, it's a bit hard to read, but we've got an equation here that says y equals x minus 3 squared. Now, in here we've got x minus 3. So our h value, how far we've shifted, isn't minus 3. It's actually the opposite. It's positive 3. So that means our turning point has moved from 0, 0. It's moved 3 places to 3, 0. And in the same way, our equation on this side is y equals x plus 5. Again, our h value, it's not plus 5, it's the opposite. It's in brackets there. The opposite of plus 5, or the negative of plus 5, it'll be negative 5. So that means our turning point has moved to negative 5, 0. Okay, so when it's in brackets there, where the turning point has moved to horizontally is the opposite of how it looks in the formula. Okay, so if it's x minus 3, it's actually shifted the turning point to the right, positive 3 places. If it's x plus 5 in the formula, it's actually moving negative 5 places, so 5 places to the left. Okay, it works the opposite way around when it's in brackets. We can also add k on the end, which moves the turning point vertically. Now, this one operates according to intuition. So if you add 2 to your equation, like we did at the very top here, let's change the color to make it a bit more consistent, x plus 2, okay, the y value of my turning point here has shifted up to 0, 2. Okay, this value, this k value, is not in brackets. It does not work the opposite way to what you think. It's outside brackets. It's not anywhere near the x term. It works according to your intuition. And similarly down here, we've got x squared minus 5. Our turning point has moved down to 0, negative 5. It moves according to intuition. The last thing to consider is dilation. So a parabola can be flattened down, or it could be stretched vertically, and this is called dilation, this stretching or compression, changing the shape of the graph. When a parabola is dilated, it still remains parabolic in shape. So the shape of the graph actually doesn't change when you dilate it, or the type of shape it has doesn't change. So if you have a parabola and dilate it, you still have another parabola. The graph just doesn't randomly change type. But it is made steeper if you stretch it, or it's made flatter or wider if you compress it. Now, dilation is affected by multiplication, this number out the front of our x squared term. And that's our dilation there. So for this red curve, that's got a dilation of 1, right? Our invisible 1 out the front. For our next one, for this orange one, that one has been dilated. Looks like it's been dilated by a factor of 4. So that's y equals 4x squared. For the black one, that one looks as though it's been dilated too by a factor of 1/4. So that one there might be y equals 1/4 x squared. Now notice the bigger the dilation number, the more it's stretched, the steeper it gets. The lower our dilation factor is, the flatter it gets, until eventually, if it's 0, it just ends up being a horizontal line, flat and straight. If our dilation becomes negative, like in this graph here, if our dilation becomes negative, we actually get our parabola turned upside down. Okay? So when it's a negative dilation, our parabola flips over upside down. If it's got a large dilation factor, it's stretched, quite steep. If it's got a low dilation factor, like 1/4, it's made a lot flatter. All right, so let's use this information to sketch a graph. So we've got our parabola quadratic written here, 2x plus 4 minus 3. Our first step is to always work out our turning point. Right? Always go for your turning point first, especially when it's written in this form. So our h value is in brackets, it's horizontal with our x horizontal variable, and remember it's the opposite to what you think. So our h value isn't positive 4, it is negative 4. But our k value, our k value is how it looks, it is intuitive there, so it's negative 3. Now that means the turning point of our parabola has coordinates negative 4, it's shifted to the left 3 places, and it's shifted down 3 places. So left 4 places, down 3 places. Here is our turning point. Now, looking at our dilation is a factor of 2. Now, how we take that into account is what we're going to do is move 1 square across and 2 squares up. Okay. In the same way, we're going to do the same on the other side. Remember, our parabola is symmetrical, either side of our turning point. So if we've gone 1 across and 2 up on the right side, we're going to go 1 across and 2 up on the left side. And there is a very rough sketch of our parabola. So get your turning point, and then use your dilation to go 1 square across, 2 up, and 1 square across, 2 up on both sides. And that gives you some dots to use to help you sketch your parabola. So students, after watching this video, you should be able to understand the transformations that can be applied to parabolas and use them to sketch new graphs.